Hey, welcome back to your favorite pre-calc class. Let's go ahead. We're going to talk about angles, arc length, and circular motion today. So there are two ways to measure angles, and that's one of those is in degrees. You know, if you go around a whole circle, that's 360 degrees. That's in degrees. That's one revolution is 360 degrees. In radians, one revolution, right? So again, this is degrees, 360 degrees all the way around. If you measure that in radians, you can also, that's called 2 pi radians all the way around. 2 pi, this is in radians. So 360 degrees or 2 pi radians. So since 360 degrees is one revolution, that's the same as 2 pi radians. If I divide both sides by 2, 180 degrees, or half a revolution, 180 degrees is the same thing as pi radians, right? So that's what we're going to use to convert from degrees to radians. So 60 degrees, here's 60 degrees. If I'm going to convert that to radians, what I'm going to do is I'm going to multiply it by pi over 180 degrees. And notice that my degree units cancel. See how the degrees cancel? So I got 60 over 180, right? So that'll leave us with 1/3. So 1 pi over 3. So 60 degrees is pi thirds radians. 60 degrees is the same as pi thirds. So negative 405. Again, if you're going from degrees to radians, right, from degrees to radians, we're just multiplying it by pi over 180 degrees. So negative 405. Let me draw negative 405. Now I'm going to go in the negative direction. There's negative 360 plus 45 more. Let me just draw. That's negative 405 degrees, right? I'm going in the negative direction. I'm also drawing this for you. So negative 405 degrees to radians. So we're going to multiply by, there's pi radians for every 180 degrees. Pi for every 180 degrees. Again, notice the degrees cancel. So I got negative 405 divided by 180. And I think both of those go into 45. Let me check that. So 405 divided by 45, that gives me 9. And 180 divided by 45 gives me 4. So this is negative 9 times pi, negative 9 pi over 4 radians, right? Negative 405. Okay, let me have you guys, you try this one. Do 30 degrees to radians. So just to check yourself, you took 30 degrees times pi over 180, and 30 over 180 gives you 1 over 6. So 1 pi over 6. All right, let's go the other way now. Let's go 4 pi thirds. 4 pi thirds. Okay, 4 pi thirds. This is in radians right now. And now we're going to go 2 degrees. And so what I'm going to do is I'm going to multiply by 180 degrees for every pi radians. So notice my pi's cancel. And now I got 180 times 4 over 3. And I know 180 divided by 3 is 60 degrees. So now I got 60 times 4 is 240 degrees. So this is a rotation of 240 degrees. 4 pi thirds into degrees. So when you're going into degrees, here's another one, negative 3 pi halves. Okay, here's negative 3 pi halves. We're trying to say, well, how much is that in degrees? We're going to multiply by 180 degrees for every pi radians. Again, notice my pi's cancel. 180 over 2 gives me 90 degrees. 90 times negative 3 is negative 270 degrees. So this is a rotation of negative 270 degrees. We can be more precise than just a degree. You know, 1 degree, remember, it takes 360 degrees to go around once. So 1 degree, if you can imagine, that's, I know I drew that too much, but 1 degree is 1/360th of the way around, right? Well, every 1 degree is made up of 60 minutes. Okay, so there's 60, if you could imagine 60 of these, 60 minutes is equal to 1 degree. So 60 of those. And then if you can think about, if I take and I blow that up, one of those little minutes, 1 minute is made up of, if you can imagine, 60 of these seconds, they're called. Okay? So let's go ahead. We're going to write 83 degrees, 24 minutes. And let me draw this for a minute. 83 degrees and a little bit. So plus 24 minutes and 13 seconds. Okay, so it's 83 point something degrees. All right? And we're going to convert it to decimal degrees. So here's what we have. We have 83 degrees plus 24 minutes, and we're going to convert that to degrees, plus 13 seconds, and we're going to convert that to degrees. Okay? So here we go. We got 83 degrees plus 24 minutes. Now remember, for every 1 degree, there are 60 minutes. Notice your minutes cancels. And so you have 24 divided by 60 there. 24 times 1 divided by 60. This is 0.4 degrees. So far I have 83 degrees plus 0.4 degrees plus, now I got to do the 13 seconds. So 13 seconds. Let's convert that to degrees. So first of all, let's convert that to minutes. For every 1 minute, there are 60 seconds. Okay? For every 1, remember, this is minutes. That's seconds. All right? Now notice, once the seconds cancel, see how I have seconds on the top and seconds on the bottom? The seconds will cancel, so I'll be left in minutes. And so I got to keep going. So I'm going to, now that I've canceled my seconds, I'm in minutes. So now I got to go, for every 1 degree, there's 60 seconds. Now notice my minutes cancel. Let me do that in black. My minutes cancel now. So I have 13 times 1 times 1 over 60 times 60, 3,600. And this is in degrees. So 13 over 3,600 gives me 0.0036111. So I have 83 degrees plus 0.4 degrees plus 0.00361 repeated degrees. So I have 83 plus that 0.4 plus that 0.0036111, and so I get 83.40361 repeated degrees. Now we want to round this to 4 decimal places. 83.4036, right? This keeps going degrees. We want to round it to that 4th position. Well, since the 1 to the right there is not 5 or bigger, I can just leave it at 0.4036. Yes, good. Brianna on that 0.0361. Any questions on that one? So that's how you take it from degrees, minutes, and seconds to convert it. Okay, and now we're going to go the other way around. No, I'll just have you take it to a certain decimal position, Brianna. Good question. All right, so let's do this next one now. Let's go from 163.36 degrees. So again, that's kind of like to here type of deal, right? 163.36 degrees, right? And so let's put that in exact form. So I have 163 degrees plus 0.36 degrees. So let's take the 0.36 and let's convert that to minutes. So for every 60 minutes, there's 1 degree. See how my degree units cancel. So I have 0.36 times 60, which is 21.6. So I have 163 degrees plus 21.6 minutes. Okay. Now the 21 part is great. I want to keep that. 163 degrees, 21 minutes. It's the 0.6 minutes that I got to keep going with. So I'm going to convert that. There's 60 seconds for every 1 minute. See how I'm going to get rid of the minutes now? So I have 0.6 times 60, which gives me 36. So I have 163 degrees, 21 minutes, and 0.6 times 60 is 36. Oh, I'm sorry, that's 36 minutes right there. 36 seconds. So 163 degrees, 21 minutes, 36 seconds. That's the same thing as 163.36 degrees. So we're going to use theta to represent an angel's measurement. In standard form, what we do is we put the vertex right on the origin. The initial side is on the x-axis, and however much we rotate that theta amount, where we end up is the terminal side. Okay, this is a positive angle if I rotate counterclockwise. So this might be like 45 degrees, positive 45 degrees. Now if I rotate, if I do same thing, I start here, but this time I rotate counterclockwise, and I end up right there. Whoops, let me do that in blue on my terminal side right there. Now this might be like negative, notice I'm going in a clockwise direction, negative 315 degrees, right? Now let's do one more where we're going to start and we're going to go around more than once. So one time around 360 degrees plus, let's say we go another 45 degrees. So 360 plus 45 Looks like we're at 405 degrees. Notice I went positive because I'm going counterclockwise again, right? So direction matters. That tells you if you have a positive or a negative angle. Let's go ahead and draw some in standard position here, like 5 pi 6. Maybe you're like me and you're looking at 5 pi 6 and you're like, gosh, I don't know where 5 pi 6 is because I'm not very good with radians. Well, if you're not very good with radians, let's convert it to degrees. There's 180 degrees for every pi radians. 180 divided by 6 gives me 30 degrees. 30 times 5, this is 150 degrees. So I'm like, oh, I can draw 150 degrees. I know 180 is halfway, so 150 degrees would be about right there. There's 150 degrees, or 5 pi 6, right? 5 pi 6 in radians is what we were trying to draw. I started here, and I rotated 5 pi 6 in the positive directions. You guys with me? So I'm into quadrant 2, right? This is, I should mention my quadrants. This is quadrant 1. This is quadrant 2, quadrant 3, quadrant 4, right? So this one ends up being into quadrant 2. All right, let's do negative 135 degrees this time. So this time I'm going to go in the negative direction. Here's negative 90, but I got to go 45 degrees more than that. So I'm about right here. There's negative 135 degrees. So negative 135. If you want, we can also, let's go ahead and practice putting that in. Whoops. Pi radians for every 180 degrees. Notice my degrees cancel, and both of those go into 135 goes into 45 3 times. 180 divided by 45, 4. So this is the same as negative 3 pi fourths in radians. All right, 8 pi thirds. 8 pi thirds. So if you're not sure, 8 pi thirds, that's in radians. Go ahead and convert it. 180 degrees over pi. 180 divided by 3 gives you 60 degrees. 60 times 8 is 480 degrees. So you're like, gosh, that's 360 degrees around once, plus another 120 degrees. So I got to go around once. There's 360 around once, plus another, here's a plus 90, there's plus 120. So I'm right there into quadrant 2. That is 8 pi thirds. That's 480 degrees. In other words, it's around once, 2 pi, plus another 120 degrees. In other words, 2 pi thirds, right? 2 pi plus 2 pi thirds, if I was to get a common denominator, that's 6 pi thirds plus 2 pi thirds. See how that's 8 pi thirds. So again, it's just 480 degrees. So coterminal angles just mean there are two angles that have the same initial side and terminal side. So for example, let's say we have an angle of 30 degrees, right? Here's 30 degrees. Well, an angle that's coterminal to that would be, if I go around once plus 30, 360 plus 30 is 390 degrees. 390 degrees is coterminal angle to 30 degrees. Okay. Another one that's coterminal, let's say I went backwards this way and negative. So all but 360. All but 30 degrees. So negative 330 degrees, negative 330 degrees is also coterminal to 30 degrees. Okay. So anything that starts and ends at the same spot is a coterminal angle. So let's do one. Find an angle coterminal to 960. Well, 960, let's draw this for a minute. 960 degrees. Well, that's 360. That's around once, plus another 360. 360 plus 360, 720. Well, what's left over to get to 960? 960 minus 720, what's that give us? Yeah, 240 exact. It's 240 degrees. So let's draw this thing. So we went around once, around again, plus another 240 degrees. Well, here's 180 plus 60. Okay, so right here, that's where I end up for 960 degrees. Okay. So what would be coterminal to that? Well, let's do it in red. 180 plus 60 gives us 240 degrees. So 240 degrees is an angle between 0 and 360 that's coterminal to 960 degrees. You could also do, let's do a negative one. What's this one in black? If the red one is 240 degrees, what's the black one? Negative how many? So negative 120. Again, you should have got that black one because you know the black one would be 240 minus 360. Negative 120 is also coterminal to 960 degrees or coterminal to 240 degrees. All right, let's do another one. Find an angle coterminal with negative 225. Let me draw negative 225. Here's negative 180 halfway, but I got to go 45 more than that. There's my negative 225 degrees. So who is coterminal to that? I want the positive angle between 0 and 360. So give me this one right there. Okay, so sorry, my thing's having issues here, but that would be 360 minus the 225, like you guys mentioned there. So 135 degrees is this positive angle that's coterminal, right? You could also do coterminal, I could do in red, 360 plus 135, which would give you, of course, 495 degrees. That's also coterminal, but it's more than 360 degrees, right? So that's the one we're looking for. All right, arc length. Let's talk about arc length for a minute. Arc length, this length of that, I know it's curved, but the length of that, if you were able to have kind of a curved ruler, right, if you will, like a measuring tape, that arc length is equal to the radius of the circle times theta. So this is the radius times theta. Theta I'm going to call my central angle right there. So that's my central angle. But this central angle has to be in radians. You cannot have this in degrees or it won't work for this formula. Okay? So let's do this first. I'm finding the arc length of a sector whose radius is 3 inches and whose central angle is pi thirds. Okay, so pi thirds, if I multiply that by 180 over pi, that's 60 degrees. Okay, so I rotate pi thirds. That's my central angle in radians. Okay, I'm trying to find my arc length here in red. So my arc length is equal to the radius r, here's my radius r, times my central angle theta. So the arc length is equal to, they tell us that this radius here is 3 inches. So I have 3 inches times my central angle, which is pi thirds. Again, you got to make sure that's in radians. It is in radians. Notice 3 over 3 cancels. So my arc length is pi inches. So this is pi. This arc length is 3.14 inches. Okay. Now let's go ahead and find a radius of a sector whose arc length is 7 pi fourths and whose central angle is 45 degrees. So let me draw this. So we have a central angle of 45 degrees, right? Here's our central angle. We're trying to find the radius, so I'm trying to find this radius of this thing, radius r. And my arc length is 7 pi fourths, okay? So we have S equals r times theta. Well, we have the S, our arc length is 7 pi fourths. We do not have the radius. We're trying to find the radius times theta, but note theta is 45 degrees. This has got to be, must be in radians, right? So we got to convert this. If I'm 45 degrees, let's convert this pi over 180 degrees, and theta ends up being pi fourths. Okay, so we have pi fourths radians. So now I can plug it in. Don't plug in 45 degrees or you'll get this dang thing wrong. So I have 7 pi fourths equals pi fourths times r, multiplied by the reciprocal, 4 over pi, 4 over pi. And it looks like my r ends up being, notice the 4's cancel, the pi's cancel. My r is 7 inches, by the way. Inches. That's the radius. Okay. I think it's worth developing this, you guys, so you kind of know where this comes from. The area is, so the area of this sector is 1/2 r squared theta. Okay, and of course theta again has to be measured in radians. So where does this come from? Well, let me just, I'll erase this in just a second. But if I take, let me draw a little sector for a minute. So here's theta with r area in there, and let me draw one for the whole. If I go all the way around a circle, let me call this theta 1. Okay. And this would be area of the entire circle, area 1. Okay. So let me set up a ratio. So if I go theta is to theta 1 would be the same proportion as the little area to the entire big area. Okay. Well, we know theta 1 all the way around in radians is how much? 360 degrees, but in radians we know that's 2 pi, right? And then we know small area we don't know, but we know the area of an entire circle is pi r squared, right? So if I go ahead and cross multiply this, I have area times 2 pi equals theta times pi r squared. So let me bring that up here. And notice if I divide both sides by 2 pi, my pi's cancel, and I have 1/2 theta r squared. Or let me write that as r squared theta. Okay, so that's where that area sector formula comes from. So I just want you to remember area is 1/2 r squared times theta. That's the area of a sector, but that's how it's developed. So it doesn't just appear magically out of nowhere. Okay. So let's go ahead and use that. Find the area of a sector of a radius of 4 inches with a central angle of 4 pi thirds. So I've rotated 4 pi thirds. I want to know this. What's the area of that sector, right? Oops, area of that sector. So the area of the sector is 1/2 r squared theta. Area of the sector would be a half. Has a radius of 4 inches. This radius is 4 inches. So 4 inches, that's being squared times our theta, which is 4 pi thirds. So we got area is 1/2 times 16, which is 8 square inches, times 4 pi over 3. So we got 8 times 4, we got 32 pi over 3 square inches. All right, find the radius of a sector given the area of the sector is 15 pi and the central angle is 150 degrees. Let's go ahead and draw this. So I'm rotating 150 degrees. Remember, 150, that's not good. I want to have that. I want that in radians, right? Well, we're trying to find the area in red right there. Oops. Area in red. Area is 1/2 r squared theta. Again, this has got to be in radians, right? But theta is 150 degrees. So let's convert that. 150 degrees times pi over 180. So 150, both of those go into 30. And that'll give me 5 pi over 6. So our find the radius. So we're solving for A. Given the area, we know the area of the sector is 15 pi. They give us that. So we have 15 pi. We don't know the radius. We also have the theta, which is 5 pi 6, or 150 degrees. Remember, we have to be in radians there. So 15 pi equals 5 pi over 12 r squared. I'm going to multiply both sides by the reciprocal, 12 over 5 pi, so those cancel. 12 over 5 pi. Notice my pi's cancel. 15 over 5 gives me a 3. 3 times 12 is 36 equals r squared. Square root, r equals plus or minus 6. And of course, r must be 6, and this would be in inches. This is originally given in square inches, right? It's got to be a positive radius, right? Length, so it's not going to be negative on that one.